Bismillahirrahmanirrahim. Hello everyone. Welcome to GFX Farhan. In this video, I will show you how to create logo fire simulation in Houdini 19. If you want this types of cool effect, then please subscribe my channel and also press the bell icon so you never miss the new updates. Let's get started. First of all, I add a geometry node and name it logo fire fx, and then I add a font node and here I type G and here I change some setting, my rotation, origin and scale. I scale it to 10 because large scale give me a best result. Then I add a remesh node and change my target size to 0.05, which add detail in my logo. Then I add a Pyro source node and connected it. I select source burn and mode to keep input. After that, I add a volume rasterize node and Pyro solver. Here I copy voxel size and paste it to relative reference. So when I change my this voxel size, it automatically change. By default, the particle size is 1. Then after that, I add a attribute noise and apply this on my P, range value 0 center, amplitude 0.15 and element size 0.35, and here I check my animate noise and pulse duration 0.5. Then I add another no attribute noise, and this time I add noise on my burn attribute. I change this to float because burn is float, not vector. My range value is 0 center, amplitude is 1, and I control this by enable remap ramp. This is my values. I change my noise pattern to overly cellular, and here I add pulse duration of 0.45. Okay, this is my position noise, this is my burn noise. I add a trail sop and change it to compute velocity, and the rest are default. Only I change it to central difference. In the Pyro solver, my voxel size is 0.05, my time scale 1.5, and here I also on single project of advection reflection. In the field tab, my dissipation is 0.35, and I also check emit density from flame. Now here we don't need to add smoke, but if I don't check this, then my fire is not rendered, and my temperature diffusion is 0.1 and my cooling rate is 0.5. Here my flame lifespan 1. In the shape tab, my buoyancy scale is 0.25. I also check my wind. My wind speed is 0.5 and wind direction is 1 in X, 0.1 in Y, and minus 0.3 in Z. I also add disturbance of 10, base block size 0.35, roughness 0.5, pulse length 0.25, max octaves 3. And here by default the disturbance apply on density. So here I also add flame. Now it's affect density and flame, and my threshold range 0.1. I also check control field by speed. If you check use control field with speed, then this is not working until you on the speed. Now in the field tab on the speed, then it's working correctly. And this is my turbulence setting. My turbulence 2.5, swirl size 1, roughness 0.5, pulse 0.25, and max octaves 3. And my threshold field temperature and control field density. Okay, let's play it. Now everything work perfectly. Disturbance, turbulence, wind. Now it's spreading. Here we need to add collision. This is my collision setting. Here I add a box and transform it. This is my setting. I transform it large because here I add my text. Now here I add a collision source, and in volume my voxel size 0.1. This is my main box and this is my VDB. Merge it and connect it to the second input. Now hit the play button. Okay, now here play with settings, with disturbance, with turbulence and buoyancy, flame lifespan. And when you happy with your result, then after that we add the spreading. So let's add spreading. Okay, so for spreading fire, first of all I add a copy to point and connect it to this input, and also I add a sphere and connect it to the second. So here our particle size is big, so here we need to lower the size. So for this I add a attribute randomize, and in attribute randomize, here I tap my attribute name to p scale and global scale to 1, and my minimum value and maximum value to 0.05. Now my particles look like this, which I want. Okay, after that I add a group swap, and in this group I enable keep in bounding regions, and in bounding regions change my center to here and connect this to cell to the group. So I want my fire start spreading or growth from this point. Okay, these are keyframes. I will talk it about later. Okay, one thing more, in the group type change it to points. Now if we check copy to points, all the points have uniform value, but we need to only this group has the initial value. So here I add a angle node. Let me remove this first, and here also change the group type to start. Okay, let me first bypass this, and here I type at rate p scale is equal to 0.0. By typing this, now my p scale value is 0, and now here I add a something like this start. If you add start, then select this. Here add not start, then it select only from our group. On the p scale of attribute randomize and select the group of start group. Okay, now here we need to drive this growth or this spread over time. So for this we need to add a solver node. In the solver, first we need to add a attribute VOP and a null and connect the previous frame to the second input and input 1 to the first input. It actually gain data from previous frame and drive it in the current frame. And in the attribute VOP I need a p scale. So for this I add a bind node and also and bind export node. So in bind node I type my name to p scale, and in a bind export node I also name it p scale. Okay, now here we need to import also our previous frame p scale. This is our current frame p scale and this is our previous. I use import point attribute, and here I connect my file and my ptnum to ptnum, and here I change my signature to float, and my attribute also I change it to p scale. Now here we need to add them. I use add node. Now we add our previous frame p scale to the current frame p scale. Now if we add them, our p scale value also increase, but we need our initial value which I use in my attribute randomize, which is 0.05. So for this I add a clamp node, and in the clamp node min is 0 and max is 0.05, and this node export our piece. Okay, now if I play, nothing happen because here we need to blur these in our other points. So here we need something more in solver. Here I add a attribute blur, and in the blur attribute I add p scale, my step size 0.5, and influence type from connectivity to proximity, and my proximity radius is 0.5 and max neighbor 4. Okay, now if I play it, the growth started, the spread is started, but it stopped at certain point. Okay, so it stopped at here and not growing up, or growing very slowly. Okay, so for fixing this, here I add attribute wrangle, and in attribute wrangle I type f because p scale is a float. At rate p scale, here is multiply is equal to 1.5. So what it means? It means here I increase the value of p scale, but our attribute verb clamp it to our initial size. So now it's spreading. Now it's working. Okay, now in solver I increase my substeps to 10 because one substep is low. But I need speed, so increase the substeps gave you the speed. Now here connect into our noise attribute noise. Now our noise also work properly. Okay, now my fire growth or my fire spread are working perfectly and nicely. Now here I add my complete text, and here if I select this, I add keyframe to this box. After 22 frame it goes from here. When this is fully spread, it jump to the X, so then F, and so on by adding keyframes. Okay, now let's check our Pyro solver. Now it's work perfectly. After that, I change my particle scale to 2 because 1 is low. In the export tab, I check convert to VDB and use 16-bit float, also check, and cull volumes well, also check. Then I add a file cache node. This is my folder name and this is my simulation cache name, and here I change from VGSEO to VDB, save to disk. After completing file cache check load from disk. This is my Pyro bake volume. I uncheck smoke, check fire. My intensity scale is 15. This is my fire intensity ramp. These are values. And here this is the default ramp of color, but I flip it, and this is my volume warp. With this node you can remove the low velocity fire or low intensity fire. Here you need a bind node and name it well, which is velocity. Then this is a length node, because with this node we can manage the length of our velocity, and with fit range we can control the length of the velocity. In the fit range, I change my source min to 0.25 and source max to 0.5. You can also increase it like 5 and 7. Then it clamp all fire 1, 2, whatever you want. Then here I add another bind node, and in here I name it temperature, because we multiply our velocity with temperature. Connect the temperature to the first input and the fit range to the second input of the velocity. And in the bind export node, I also name it temperature. Okay, so our whole setup of simulation is ready. Now here I show you the background. In the background, I copy font node from FireFX into background, and here I add a poly extrude node and extrude it of 0.5. Then I add a boolean node, and here I add a grid node. This is my grid size, and I connect my grid to the first input of the boolean, and the logo to the second input of the boolean. And in the boolean my operation is subtract. Our logo is subtracted from the grid. Now here I add a another poly extrude node to extrude it of 0.1, something like this. And here I add a UV project. If you want to add some textures, then you need to add a UV project node. Here this is the color, and then I also add a UV project node to this grid and add this add color and merge it, add a normal. Okay, and here in material plate I use a simple material. Okay, and I apply to the geometry node. Here I add a distance light. This is my distance light, and these are the cameras. Select your camera in the render output, render it as EXR, and here two things needed. Add some extra image planes. One is combined light, per light, and second is combine emission. Combine emission render only fires with light, and the combined light per component is our background. Make sure check these two, because with the help of these we can work properly in compositing. So our video is completed, and in the next video is about the compositing of this fire, because without compositing you cannot achieve the right result. So see you in another video. Goodbye.